In this unit, we're going to be looking at different coordinate systems and how to transform between them. So before we even get into this, a good question to ask is why should we even bother learning about different coordinate systems? Maybe you're already pretty comfortable with our Cartesian or our rectangular coordinate systems, so why do we need to learn about different ones? And so that's a good valid question, but what we're going to see is that choosing an appropriate coordinate system is going to allow us to make problems a lot easier. So choosing an appropriate, I'm just going to abbreviate this as coordinate system, can make a problem much easier. And so we're going to see that sort of how that plays out in the math in some later units, but let's think about sort of a simple example. So for example, we can think about transmission lines. So of course with transmission lines we're basically sending power along cables, which of course have a cylindrical symmetry. So if we look at sort of a cross-sectional piece of that transmission line, we notice that we have cylindrical symmetry, which means that our cylindrical coordinate system is going to make our math a lot easier as we go to try to determine various field strengths, various forces within that transmission line or near that transmission line. So that's just sort of one general example, but again, we're going to get more into the details. We're going to see how the math can be made easier in later units. So in general, we're going to look at 3 different coordinate systems. And so this will be a relatively short unit. We're going to look at our 3 coordinate systems, work a few examples about how to go back and forth between the different ones, and then we're going to move on into our vector calculus. So the 3 coordinate systems that we're going to talk about are Cartesian or rectangular, which we've already sort of dealt with in chapter 1. And so this is sort of the standard that most people are going to be familiar with, that you've seen probably since high school or somewhere around that time frame. The second one I mentioned above with our transmission line example is our cylindrical coordinates. And we'll see what that is in a couple videos from now. And then our third and final one we're going to look at is spherical coordinates. And again, there's going to be different times when one of these is going to be more appropriate than the other. That doesn't mean we have to use a certain one. It just means it's going to make our equations, our math, all of that a little bit easier. So something to note is that all 3 of these systems are something called orthogonal systems. So all 3 are what we call orthogonal systems. And so remember, we said orthogonal is really just another word for perpendicular. So what this means is that our coordinate surfaces are mutually perpendicular. So they're all perpendicular to one another. And that doesn't really make a whole lot of sense right now because we've not talked about what our coordinate surfaces are for cylindrical and spherical, but we'll get into that in detail in some later videos. But right now, just note that all of these are orthogonal systems, so our coordinate surfaces are all mutually perpendicular. Another thing to note is that our concepts from chapter 1 still apply here. So unit vectors, vector addition, all of that stuff still applies in our cylindrical and our spherical coordinates as well. We're going to see, of course, the points are defined a little differently, but the basic concepts still apply. So chapter 1 concepts apply. And one other thing to keep in mind too is if we have some point P out in space, so say we have some point P here, using different coordinate systems doesn't actually move this point. So using a different coordinate system doesn't change the location or the properties or anything of that of the point. So it doesn't change the location, let's say. So basically all we're doing is we're changing how we define that point. And so again, this is something we can talk about a little easier once we've seen what our cylindrical coordinate system's like and our spherical coordinate system's like. But the main thing to keep in mind is that we're not actually changing anything when we do these transformations between coordinate systems. We're describing the same thing in a different form. So a very important thing to keep in mind.